Let's take a few minutes to examine how to read table 8.4 in the text on page 210, which reports or reproduces a table from a paper by Jonathan Morduch and Ashish Garg on sibling rivalry and gender implications in using data from Ghana. What Morduch and Garg do, and others have since replicated this analysis, is for every child they calculate something that we, and it's common in the literature, is called the z-score, which is a standardized measure of typically some health outcome, but could also be used for grading, a grade on an exam that's a standardized test, any other kind of outcome where there's a well-known standard and distribution of the variance of that standard. And the way we compute this standardized outcome is we take, for instance, in our case, Morduch and Garg's case, the height of the child, given the age of the child. Then we subtract from that height the reference group's height. The reference group here is the same age as the child that we're considering. So if we're looking at a 8-year-old, then we're subtracting the height of the normal height of an 8-year-old. If we're looking at a 2-year-old, we're subtracting the normal height of a 2-year-old. And then we divide the difference in the heights by the standard deviation of heights for the reference group. So what we end up with is how many standard deviations this person's height is from the reference group's height. And we'll just take a little specific example. We might have a child whose height is 97 centimeters. The reference group's height is 105 centimeters. The standard deviation for the reference group is 4 centimeters. So we have a gap of 8 centimeters in height between this child and the reference group. And since the standard deviation is 4, 8 divided by 4 means the child is 2 standard deviations below the reference height. So what Morduch and Garg do is compute that z-score for every child in their sample from Ghana, and then compute the average of those z-scores according to the number of siblings that the child has and the number of sisters that the child has. And we end up with a table where we have the number of sisters on being controlled for on the vertical axis, and then across we have the number of siblings, 4, 5, 6, etc. So we examine this table going two ways. First, we note that as the number of siblings increases, the average child in each one of those bins with more siblings, their z-score increases, the absolute value increases, that is the negative z-score increases in magnitude. They get, having more siblings is worse for your height for weight or your weight for height. But more importantly, Morduch and Garg note that there's a gender dimension to this, and we'll look here at the case when a child has 4 siblings, and in the sample we're looking at the average here of their z-score of weight for age for children who have 4 siblings where none of the 4 siblings are sisters, that is, all of them are brothers, and their average z-score is negative 1.74. As the number of siblings increases in terms of being sisters, so when we compare that number with the average of minus 1.34 is the average z-score for children who are in families where they have 4 siblings, but 3 of those siblings are girls, so they're considerably less far away from their height for age z-score. So having sisters, in that sense, all else equal, having sisters is better. If you're going to be a child in a large family, you're better off when you have more sisters. And that's basically the result, which again is very consistent with the pattern of gender discrimination, also consistent with other kinds of parental behaviors, and sorting out exactly what is driving the parental behavior that leads to this pattern is still an area of much open research.